Today we're talking about linear functions. What's up guys, Mathron here, and today you'll be getting one of the best insights ever about linear functions. To let you know guys that I know what I'm talking about, I've been doing maths for a really long time, during which I was able to be one of the top students of my high school, college, and even graduate school. I got a job in finance, and here I am giving you the greatest advice ever. I mean the greatest in the business. So I want to start this off by a quick question, which is going to be really important for the rest, which is, what is exactly a linear function? Matter of fact, I want to ask you, what is a function before everything? Now, you have no clue what a function is. You're just using it in your math classes and whatnot. But essentially, a function is a transformation of one set of numbers. What am I doing here? One set of numbers to another set. That's as simple as that. And let's imagine this is set number 1. It contains one number, which is the number 2, let's say. Set number 2 with one single element in it, which is the number 5. Now, there's plenty of functions that we can define and that transform the set 1 to the set 2. For example, f of x is x plus 3. Now if you tell me, what if f of 2, this is 2 plus 3, which is 5. Now that's the transformation. Now if you tell me, what is f of 0, I'm going to tell you there's no f of 0 because 0 is not in the definition set of f. Now f is only defined on this set of numbers. Alright, so that being said, a linear function is simply a transformation which is done in a linear way. A question arises that says, what do we mean by a linearly transformed number? The answer is this. A linear transformation is either add or subtract something to the number. And by something I mean a real number. Now add and subtract is basically the same thing, because subtracting a number is just adding minus that number. I hope you makes sense for you. Now that's the first option. The second option is multiply or divide by a number. Alright, all that being said, every single function on earth can be written under a certain form that I'm going to show you. If you bring me a linear function that we cannot write under this form, I can give you let's say $1,000. Let's say $2,000, alright? Matter of fact, I'm going to give you my YouTube channel. Alright, so this is the form that every linear function would take. A and B being real numbers and x variable. Alright, so A and B real. Now these two numbers actually represent something very important in the function. Matter of fact, they define the function. If you give me 1 as A and 2 as B, that defines a single function, which is x plus 2. Now commonly these two numbers A and B, they're called the slope and the y-intercept. Why is that? I'm going to show you why in a second. All this is going to be very easy to understand because it'll make sense to you. Now 1, the slope. What does that mean exactly? Now the slope in English is the slope. And why is that called the slope exactly? Now let's draw a function, for example, here. That's the plot of a function. Let's change the color. Let's say this is the function. Okay? Now how I define the slope is, it's kind of the speed by which this transformation is done to the number, to the variable x. Now the speed of the transformation is actually the slope of the plot that you see right here. Why is that? That is because if you take two numbers, let's say this is number 1 variable in the x-axis, this is 2. The slope of this function I guess it's gonna be 1 according to my calculations and how I see things, because I'm gonna teach you how you can guess the slope just by looking at the plot. And this is 1, I mean not exactly 1, let's say this is 1.1 and this is 2.1. Okay, we add 1 to the x's and we get 1 added to the y's, to the output of the function. Now if the slope is 2, for example, and we add 1 to the x's, we'll be adding 2 to the y's, to the outputs, because the slope is bigger. And graphically this is gonna look like this pretty much. This is probably a slope of 2, and as you can see the slope is bigger. Now if that's 1 and that is 2, I guess this should be 3 and this should be 5. Something like that. You know the difference now between this one and this one. Now let's talk about the y-intercepts and how you can calculate the y-intercept, but based on the two possible things, the plot or the analytical form of the function, I mean how it's written. Let's say I have a function f of x is equal divided by 64x plus 2x minus 33. I know guys that your teachers give you very complicated questions, so calculating the y-intercept of this is so simple, so easy. Now if you want to calculate the slope of the function, what you do is you take all the x's and you put them in one single basket. Now 3, 6. Now it's up to you to calculate that number right here, but it's fairly simple. That would be the slope, because that's what we multiply by x. You know, remember that's the a and that's the b, minus 33. That's the a and that's the b. So simple. If you want to calculate the b without having to do that transformation that I just did between this line and this one, you just replace x by 0. So in that case, f of 0 is 0 plus 0 minus 33. So f of 0 is exactly b, which is the y-intercept. Now graphically, what does that look like? If we draw the plot of the function, let's say that's a function right here. Plot looks like this. F of 0 is this. That's f of 0. Why? Because probably your teacher said that this is the y-intercept. This is where the plot crosses the y-axis, and you just learned that by heart without even understanding why. But why is really the question that you should ask yourself every time your teacher said anything. So now this is the y-intercept because that's simply f of 0. Because that's 0 right here in the x-axis. That's 0. And f of 0 is just the image of f by 0, which is this point. Because if we take 5, for example, right here, where is f of 5? It's that point right here. Now f of 0 should be this. Logic makes sense. Now let's try to look at some of the most common exercises that you should get normally. Actually, just realized that we can type here. Type. Why am I bothering every time trying to type with my with that little drawing pencil? Whatever. The exercise is, give me the slope-intercept form of the line passing through these two elements. That's these 2 points, x1, y1, and x2, y2. Now, graphically, this looks like this. So if you give me these 2 points right here, x1, y1, let's suppose this is x1. Now, in the exercise, they're going to give you numbers. So, for example, 0, 1, and 2, 3, for example. Now this x1, y1, just as an example. Now this is the point x1, y1. And let's say this is x2. Okay, y2. So this is the point x2, y2. Now you can imagine that the plot of the function looks something like that. Now you have the plot, but you don't have the slope-intercept form, which I just showed you. It's written as f of x equals to a times x plus b. Now the way to solve this is so simple. What you do normally is you have kind of a system, like two equations to solve. What you do is you take the first one. Now we know that the line passes through x1, y1, so that tells us that f of x1 is y1. So f of x1, which is what? A multiplied by x1 plus b, that equals to y1. And as well as f of x2, which is equals to a multiplied by x2 plus b, because that's the form of f, and that equals to y2 because the line passes through x2, y2. Now what we do is we calculate y1 minus y2. Why do we do that? I mean, let me write that. So easy. y1 minus y2. Why do I do this exactly? I just want to eliminate the b so I can be left with the a, because that's going to give me ax1 plus b minus ax2 plus b. What does that mean? It means that y1 minus y2 is equal to ax1 minus ax2. The b's disappeared, which is equal to a multiplied by x1 minus x2. What's that telling us? It tells us that a is equal to y1 minus y2 divided by x1 minus x2. Now probably you have already seen this formula somewhere, and this is where it comes from. Okay, this is where it comes from. Now once you have a, it's so simple to have b, because you should probably go with one equation or the other one. So for example, if you go with the first equation, the only thing unknown in this equation is b, because you know what a is, you know x1, and you know y1. So you're left with b, and b would be what? B would be simply y1, for example, minus ax1, which is y1, all that multiplied by x1. I hope you get the idea. Now we have a and b. Oh, what have I done here? We have a and b, so we have the slope-intercept form of the line passing through these 2 points. Now guys, as you know, to keep the video short, I cannot give you every single detail that I know about linear functions. So if you have any questions, please drop them in the comments. I'll be more than happy to answer all of you guys' questions. And by the way, if you like my Joker poster, give this video a thumbs up. It will really help this grow in YouTube channel. And that would support me and make me want to do more videos for you guys. So that being said, thank you so much for watching, and see you guys in the next video.